All right. So I'd like to thank, first off, Tom Huda for giving the first half of my presentation yesterday, because when I practiced this, I went over by like a half hour, so that should do about right. We're going to talk a little bit today about what it means to do route traversal in an Ember application. But I want to start by building some foundations as to what a URL is. So after a year of hearing "stop breaking the web," I'd say that we've finally got people starting to take heed. Usage of URLs in JavaScript applications is closely following trends that you can easily find by searching Google. And fortunately, though, everybody here gets URLs out of the box. Otherwise, this might be a really, really, really short presentation. So I like to think of URLs as the API for your site's end users. It's typically the lowest level of abstraction that a normal user will ever use to interface with your site. But not all URLs are created the same or even close to the same. So my mental model for URLs has them falling into one of two categories. The first category is resources. And that's because they look a whole lot like the REST-ish APIs that are beat into your head by the HTTP zealots. So I've reused the term resources, which the same HTTP zealots will probably take offense with. So resources are typically available at any point in time in your application. They don't appreciably change the state of your application when you actually visit the resource. And you usually want them in your history stack. Now, I try and make sure all of my resources are pluralized nouns if they are actually collections, think array controllers, or singular nouns if they're just a one-off item, so controller or object controller. I make a distinction, though, between resources and actions. Action routes are a little bit different. Underneath the hood, we're talking post, we're talking put, we're talking patch. But your users don't know that. So we provide a friendly interface to the REST holy wars, and we make sure that a user of our application can actually perform the correct actions against the API. So an action route. An action route is something that receives all of the user's input in one fell swoop. Upon completion of all of the information gathering on that one route, the user will be presented with either flash messaging or the newly created resource, or even just a clearly visible proof that, yes, your application has changed in the case of something like a login. So the user successfully submits something on this action route. You typically find yourself in a situation where you want to completely reset the controller. Or in the cases where you don't, it's a highly repetitive task where the user is changing one out of like 13 fields on that particular page, say filling out a timesheet. So you get to do either one of those in a JavaScript app, in contrast really with a server-rendered application. Most particularly when you have a server-rendered application, if you depart that route, the entire set of information that the user has entered is discarded. It's poof, gone. And the reason it's gone is because it's been evicted. It's literally been evicted. And the only way you can get it back is if you're very lucky and your browser has saved you with its back-forward cache. But we get to choose how we handle that, and I'd like to thank Alex Machnier for actually taking a swing at that. Make sure everybody bugs him as to when that's going to be available, because I want it yesterday. For action route URLs, I try and make sure that they always contain a verb. If you look at all of the ones highlighted in blue, you'll notice that some of them have slightly odd names for what they are, but that's because I like verbs and parts of speech. That's what I get for being a nerd. So there's a third type, and this is where I am very, very particular, and I'm of the opinion that we are only ever looking at 3 separate types. If you need to perform a series of actions divided across routes, if you're changing the application state not in one single route, instead across multiple routes which combine to merge into a completed application state, we can now say, that's a different problem set entirely, and I'm calling that a flow. Now, we want to make sure that progression through a flow is possible to be intermediated by async calls to the server. We want to make sure that we have collected all of the information we need from the user in order to proceed, so that's validation. All of these things need to be taken into account when you're talking about a flow. But when a user is working through a flow, when they load a URL outside of the flow, just like in an action, we need to decide how we handle that. So in an action, if you depart from a page that you've started entering your information in, and you move over to a new page, what happens? Well, you get to choose. Same with a flow. We want to make sure that the state machine that you have for your flow allows you to jump right back in to that flow at any point in time. So I'm starting to reveal computer science terms here, so I'm going to try and catch up to the previous presentation. I'm not going to get anywhere close. So in terms of actual computer science terms, we're talking about a directed graph with an attached state machine. So the edges of the graphs indicate the decision points, and those decision points are based upon the actual application state, and the state mutations themselves occur on the routes, which are the nodes in the graph. So looking at this on the screen, you can see that we've got our login node, and that's where you would start to make your mutations, and then you check the status of those mutations on that edge. So let's figure out how we can model that behavior. Getting flows right is hard, like seriously hard. Also incredibly annoying. You have to correctly get and completely get every single permutation listed. And this is a great day. So if your team's working on this, call in sick. It's not worth being there. Now, the approach I propose is very, very similar to Ryan's approach, but his was more tailored to the actual interface components and what the user's perception of what is happening is. And he says at the end of his presentation that throw it away. All diagrams are meant to be thrown away in his little blog post. I don't agree with that. So I harassed Tom into passing me his slides. So we want to avoid flow spaghetti. So what that means is we need to have this very cleanly defined, cleanly laid out. And so it's a real problem, and we should probably figure out how we should handle this situation. So step one, we want to inventory our routes. Easy. Open up router.js and leave that open on your screen while everybody is watching that and all of the additional information in the whiteboard and everything else that you're going to need to actually get this right. Two, I always start by listing linear paths. You don't need to try and follow along with this. This is more just to give you a sense of the first half of what our login flow traversal path could look like depending upon what you're up against. So this is a thought process. This is your goal for doing this is to make sure that you're thinking in the right way and that you're able to actually have enough space when you draw your node graph, because it looks terrible. There's all sorts of fun things you can do to help with this. There's actually a Java library that will make sure that all of the arrows point to the right if you're only doing forward traversal. But I always like to start with the longest chain first from my actual list to make sure that I leave myself enough space so that this spaghetti actually is relatively reasonable and easy to see. Now, after you've got your actual routes, you need to identify what the state change is or what the state is required to be in order to traverse a particular edge of that graph. So every mutation to an application state actually occurs at a node, which is a route. It happens either in an action, it happens through a binding, it happens somewhere on a rendered route, because that's when a user can interact with you. Even if it's a asynchronous load of information through before model, after model, all of that also happens again on a route. Thank you, Mr. Router. So we want to make sure that we contain our state modification in a nice clean location so that when we move across a different gap into a new route, we can actually check the state correctly. Now, we want to actually describe the state for every single one of these. We want a complete enumeration of the state that allows that progression, one, or we want a enumeration that is weighted. So we say this particular property must be true, but if I pass in a weight on that, that means I'm changing the order in which we're evaluating these. So if I pass a weight from login to this is select delivery method for your one-time password, if I say that this is the first one that I attempt, then I want to make sure that that one is my primary, so I don't have to specify as much state information. I typically prefer to specify the entire state because following through on weights can lead to surprising behavior. Then every now and then you say, uh-oh. Users, they don't care for your best laid plans in any way, shape, or form. The moment you think you can say, this is everywhere a user can go, they press the back button. And that's a pain. So what do you want to do? You want to actually go through your application after you've modeled every single forward traversal and figure out what it would be going backwards. So fortunately, I'm building a login application. It's like a fish trap. You go in, you don't come out. The only thing here that you can actually change during your login is, my phone is upstairs. I don't want to go get it. I'm instead going to have you send this to my email. So you can go back from trying to actually enter your code to selecting your delivery method. Now, you go back in, you draw all of your new additional fun edges, and this is where what used to be a nice, friendly, directed acyclic graph is now just a directed graph, and that makes it about twice as much fun. And so then you're done, except for the routes you forgot. And then you go back and you add all of those in, and then you can start to see this is exactly the problem with coming up with what is a flow. It's a pain in the ass. It's a very, very detailed process. But at the end of it, you have something that is incredibly valuable. You have a state machine that describes exactly how a user can move through your application. You have a nice, pretty picture that you can present to your business people. And they say, hey, I understand how a user is actually going to move through this application. You have a nice, pretty picture so that when Joe Blow, junior developer, just signs up for your company and you give him commit privs on day one, he can very quickly grok how a user actually moves through your application. It's actually a really important diagram, and under no circumstances should it be thrown away. So, a few important things. One, sir not appearing in this presentation. The Ember J.J. Abrams resolver, however nice, is not going to be appearing today. An earlier implementation of this approach actually abused the Ember resolver, and you should never do that. It's a really terrible thing to do. So if you actually have any questions, I can tell you all about how you should never load a route on top of itself using the Ember resolver. It just does not play nicely. That being said, I am using Ember CLI, which uses the resolver underneath the hood, so check. All right, so number 2, don't break the web. I think everybody here has heard that, and the rumor I've heard is that you'll catch the measles if you do break the web. So name your routes very well, make sure your users can actually use your URLs, and that you can successfully navigate your site using the location bar. Oh, and one more thing, don't pollute your user's history stack. That's really annoying. Number 3, Ember Router is awesome. I've said this now twice, so this is the third time. That being said, I really think we should have done a really serious rework before we launched 1.0, because this is just terrible right now. All right, sorry, throw away. So Ember's built-in fully asynchronous routing gives us really the primitives that we need to make this possible without going and finding the nearest tall building and jumping off. So let's spend a few minutes looking at what this application might actually look like. So we're going to hop over here, and we're going to look at a fully built online banking application. And actually, let me do one more thing. That's wrong focus. So here's the URL. I built this with my good friend and colleague, Alex DiLiberto. I'd like to thank him for his help in actually pulling this together. And on Monday, he actually gave one of the bonus presentations called Extending Ember with Analytics. Check it out after the conference is over. I'm sure you will be pleased. And he and I will be both contributing more to this project as we get it wrapped up. So now get back out of this and head over here. And so what we want to do is we want to look at what it looks like to actually traverse this flow. So by default, I actually have a state machine that's all set up. I'm going to log in. It doesn't actually validate usernames and passwords, so this is really nice. Tell it to log in. Ultra secure, you should use Ally for your online banking needs. You can add and remove phone numbers, and it all works just the way you might expect. But the other fun thing is I used a library known as libPhoneNumber, which is a Google library. And I typed in that really weird wonky thing, and it actually knew that it was a phone number. It formatted it correctly, and then it saved it off for me so that I can actually use it. Check it out. It's as part of the repo. You can use it anytime you want. Then I continue. Since I just set up my one-time password, I assume that the user didn't put in two communication mechanisms that they couldn't reach. So instead, I want to actually go ahead and tell them to register the device and tell them to submit. They have to agree to receive documents electronically, except blah, blah, blah. And then if you see a tour, they blew it. Well, our design is great. So go to your accounts, and then you've actually hit your actual logged-in bank account. Now, we're going to change that. I'm going to log out, and I'm going to come back to log in, and I'm going to hard refresh. And I'm going to simply say, whoops, wrong focus again. Let's come over to our console here and paste in. All right, I just changed the state of my application. I haven't done anything else. All I did was add in one additional fixture that tells me what the state of my application is using Instructure's fun toys. I'm going to tell it to log in. It took me directly to accounts. All I did was change the state, and it knew exactly where it needed to go. Now let's do it again, this time with a slightly different set of definitions. Log back out, go to log in, hard refresh, and paste in. And let's log in, and we'll see where we go. So this time, it knows that I have two delivery methods. It's going to tell me that I want to select one and submit it, enter my one-time password, ultra secure, and you register your device, and now you're again at your accounts page. All that's happened so far is you've changed the state of your application, and you get all of the route traversal relatively for free. So how did we do this? So coding a flow, at first glance, the diagram that we actually built looks terrible, incredibly complex and painful to build. But really, it's not that bad to actually turn it into code. So this code actually works. When you check it out, note that this is the naive version, and you really shouldn't use it. There's a better version coming up later. So you load the session state. Your general strategy is you want to load the session state from a route global injection. You want to reset the controller, if necessary, on setup controller. You want to delegate the identification of where you're going to go next to the route that you are currently on. You want to traverse the longest possible route so that when you actually are at a particular route, you know you've visited every single possibility. Once you've visited every single possibility, then you can say, for sure, that I went on the correct path through my flow. So it's a visit every node as part of the actual process. That's wasteful and slow. But it works. And so here's how you would do that. You start by actually creating your session object. You take it and you inject it into every single route, and then you make it available on all of the routes using all these fun toys that are provided as primitives inside of Ember. This is register and inject, which we actually need a little bit more documentation on. And then in the actual routes, typically when it comes to redirection, you want to make sure that you do all of that in the before model hook. You don't care to load the model. You don't want to try and do additional unnecessary functionality if you don't need to be there. So you try and get out of it as soon as possible. So in this case, because we don't have it nicely set up, we have to check all of the conditions as to whether or not you should be in that route on that route. And quick tangent here, replace with is awesome. You remember me saying don't pollute your browser's history stack? Replace with is an alternative to transition to, but it's really, really, really well suited to flows. Because sometimes you don't want the user to press that back button and get that other page. So browser stack history is pretty much just a stack. This pops the stack at your current pointer and pushes on the new location. It's perfect. So, and then you've got an action. And I'm going to pause for a second and take a drink. So, most of the logic flow for traversing between routes actually occurs inside of actions. You have an action, say, called authenticate. In this case, we're checking to make sure that the user's one-time password is valid. So you go in, you make your request to authenticate, you set your session value for authenticated to true if the authentication actually checks out. And then in the event that it does, you go to the next node in the entire process. Again, this is actually really, really, really redundant. Let's go back to before model. 1, 2. Just like a little doctor's office. It's redundant. Why do we have all of this extra unnecessary code? So we want to come up with an improved approach. And this is the using flows part of the presentation. So what we want to do is we want to define all of our progression in a separate location. We want one singular place to go look for how you're going to move through your application. We want to load the flow and that flow state. So not just the actual directed graph. We also want to know where the user is in that directed graph and what state the user is in. And we want to rely on Alex Machnier's new primitive for repopulating controller state. Excuse me. And we want to delegate the identification of where to go to the flow. We don't want to actually be responsible for handling the next step in the process in the actual routes themselves. And then we want to call back into the flow to progress. And your flow underneath the hood tracks all of the fun little edges that you've traversed in case, for example, you have a setup complete page, which we do, and that setup complete page looks something like this. Which routes did you visit? Oh, you visited these 4? Tell the user that, congratulations, you successfully set up your one-time password. You successfully reset your password. You successfully did all of these things. Well, can you imagine trying to figure out what a user did when you actually don't know where they have been? It gets really, really wonky really, really fast. So you start with a definition. This is a relatively simple definition file. There are 2 approaches to actually designing a directed graph. You can either have an edge list or an adjacency matrix. I'll take 2 guesses as to whether or not this is an adjacency matrix. So we're going to try and move from login.index to accounts.index. It's the primary thing that you want to do, and the only thing that you need to check is whether or not they are identified, which is you know who the user is, and then if they're authenticated, which means they have completed their one-time password validation, or they were on a device that was recognized to begin with. So we're going to use an edge list. And then you want to inject your login flow into your routes. So looks very, very similar to the other approach. It's available everywhere else, except it's namespaced, if you will, to flow in the actual can I use the word container? In the container. And then before model, it's actually relatively easy. Right now, I don't have a good way to force myself over top of before model. I didn't want to try and do that in version 1. And so right now it says this.get flow.check. So it calls into the current flow. You note that I didn't say load the login flow. I said get flow. And so flow magically is the current flow. So you could have multiple flows in your site, not just a login. You could have a checkout. And you could hop between them, and you want to be able to jump in and out of whichever state machine that you need. And so we want to grab the current flow and check to see whether or not I'm allowed to be where I am and where I would need to go in the event that I do need to go somewhere else. So now you have a nice little action. You do your normal action, except you saved off a copy to the current flow. And you perform your asynchronous validation with your server, and then you call back into the flow to tell it to progress. The only thing you're checking here is, the only thing that you're actually doing here is setting state on the flow inside of your actual routes, which is quite valid. That's where you would want to have information come in. But you are not doing any processing of that information directly inside of your route, which means that you have a nice, concise location anytime you want to make a change. And so it's called Ember Flows. It's vaporware. I swore I was not going to come up here and present on something that wasn't ready. I'm probably 3 functions away from complete. I have a directed graph traversal function that I still need to write. I've got Guido van Rossum's implementation in Python open on my computer right now. So it's coming. It's coming very, very soon, and it's going to be a lot of fun, and this is how we're solving our problems at Ally, and we suspect that this might be something that's easily generalizable across all of the problem spaces that you guys run into yourselves. And so thank you. I very much appreciate the opportunity to come up here and speak, and there's resources in the slide deck. So.